Alright, so today's day 14 and LeetCode released a brand new problem, so not seen on LeetCode before. And this problem is given a string S and a matrix shift, where shift tells you which direction to shift in and how much to shift in that direction. We want to output the final string after all the operations. So they give us an example. In here, we have ABC. 0 says go left by 1, so we do that. 1 says go right by 2, so we do that. And we end up with the final string of cab. Okay, let's dive into it. So let's first start off with an example. Realize that will help us realize that we don't need to perform every single command that they tell us. We don't need to perform every single shift. So for example, if they tell us to shift left, we get a string BCA here. And then tell us to shift right. This A goes to the end, so we have ABC. And then they tell us to shift right again, we have CAB. But this is the same thing as just telling us to shift right by once. So if we had ABC, shift right by once, CAB. So what we notice here is that this and these two cancel out. So only leaving us with the last one. We can actually visualize this a little bit better with a line graph. So if we had something like 0, which means go left. So 0 tells us to go left by 1, we will do that. And then when we see green, which is go right, we'll go right by 2. 1, 2. And that leaves us off with a final count of go right by only a single one. So how do we get to this final number? Well, it'd be nice if we could do something like this. When we see a 0, we append a negative in front. And then when we see a 1, we append a positive in front. Then when we do -1 plus 2, we'll get our answer of 1. The equation that we're going to use to make this happen is going to be, so let's call this the direction. We're going to do 2 times the direction minus 1. So in 0, we're going to get 2 times 0 minus 1, which is going to equal -1. And with 1, we're going to get 2 times 1, which is equal to 2, minus 1 is going to give us 1. So these two equations will help us get -1 and 1, so that we can do this times the amount, where this is the amount, to give us -1 and +2. That way when we sum it all up together, we get our final shift, what we really need to shift by. Okay, so let's code this out and then we'll continue from there. So in here, we want to figure out what our final shift is. So our final shift, we'll start off with 0, and we're going to read through our shift matrix. So int command or operation in our shift. Final shift, we're going to add it to 2 times command at 0, which is the direction, minus 1, and then times command at 1. So that's the amount to shift by. Okay. So now that gives us the final shift amount. So continuing on, what we want to do next is figure out how to shift. But before we do that, there's actually another optimization we could do here, is to notice what happens when we shift past the length of the array. So that would be right here. So in this example, we have shift by 1. So let's go ahead and do that. So if we shift to the right by 1, so remember now positive means shift by right, and then negative means shift by left. So if we shift by 1, we're going to get CAB here. By 1 again, we're going to get B So we always look at the end, right? Here we go to CAB, here we go to BCA, and then here we go back to ABC, and then here CAB, BCA. So you can see that the amount of unique shifts only happen from 0 to 2. So this was with a length of 3. So our string has a length of 3, and you can see it's only really 0, plus 1, plus 2. All the rest of this, plus 3, plus 4, plus 5, it really is the same thing as plus 1, plus 2. So what we want is some sort of equation that can go 0, we get 0, 1 to 1, 2, 2, 3, tell us like really this is just shifting by 0, 4, 1, 5, 2. So the thing that we're going to put here in the middle to let this happen, we are going to do something called the modulo operator. So we're going to modulo it by the length of our string. So the modulo operator gives us the remainder after you divide it by the length. So here, if we do 3 divided by 3, you're going to get 1 with no remainder. 4, we're going to get 4 divided by 3 equals 1 with a remainder of 1. Or in other words, 1.33, blah, blah, blah. But this remainder, we can get it with the modulo operator. So it looks a little bit like, so if I had to shift this over a bit, it will look something like this. You modulo by 3, modulo by 3, modulo by 3, all the way down. So this gives us a very precise amount to shift by for the very, very end. Okay, so we have that done. So we can do something like here. So we want to say final shift is equal to final shift modulo the length of the array. Something like that. You can put a modulo here if you want, and then delete this to have the same meaning. But for now, let's just consider the case where our shift is positive. Because if our shift is negative, we want to actually reverse the negative first before we do our modulo operator. Okay, so continuing on from there, we now know that with a length of 3, we really only have 0, plus 1, plus 2. And then we also know that that gave us the amount of CAB and BCA. So if we notice here, this is the same as this index. So we're trying to figure out what is the start of our new string. So what is I in terms of, here is 0, 1, 2. And what is the start index of this new string that we created when we shifted by 1? So here, it's going to be 2. And then for this one, it's B. And B is this one. And this is going to be 1. So we have 0, and then 2, 1, when we're shifting it by 1, 2. And then what about the negative case? We haven't gone into that much. So with the negative case, we have, not a good color, -1 and -2. And then that means we're shifting by the left. So here we have BCA and then CAB. So again, what we'll do here is now here is there, and C went to here. So if we fill out our I's, this is going to actually just be 1 and 2. So it seems like with the negative, so when we're shifting left, the relationship between how much we shift by and where we start off in our index is just shift equals to negative I. So that one is the easy case. But what about for this one? It seems like when we're shifting, we're reading from the top in reverse. So when we shift by 1, we read here. When we shift by 2, we read here to start off with. So this relationship is going to be, let's see, it will be, the amount that we want to shift by will be, so let's say we have L is equal to 3, the length of the string is equal to 3. We have 3 minus shift. It's going to give us I. In other words, L minus shift. Okay, so knowing these two, we can continue on with our coding. So in our coding, we want to figure out, what is this, in our new string, this is the first index, or the index to the first character of our new string. And int I, let's just have it equal to 0 for now. And here we are shifting right, and we just said that I is going to be equal to the length of our string minus our final shift. And in here, I would just be equal to our final shift because we already did the negation here. So now I would just be equal to our final shift. Okay, so continuing on from there, I guess we could do if final shift is equal to 0. So meaning like for a length of 3, we rotated 0 times or 3 times or 6 times, continuing on from there. Let's just return S. We know nothing will change. And then at the top, I suppose we could put in some guards. So if S is null, or S.length is less than or equal to 1, we can always just return S. Okay, so now we want to build up our new string, our final string. So we'll use a string builder for that. And we also want to get all the characters in our string. So we'll have chars equals to s.toCharArray. Perfect. And now we want to build up our new string. Our new string is going to have, not I. Let's do another one. Let's say count. Our new string is going to have the same length as our old string. So we want to loop over it once. But now we're going to append, let's see, chars at I. So remember that I here is the index to the first character of our new string. So here we'll do that. We'll I++ to advance to the next character. But remember, let's say we're here and we're at C. If we advance by 1, we don't want it to go to here, which will create an exception. We want it to loop all the way back to A. So we want to have a check here. If I is greater than or equal to the length of the array, then what we want is for set to I back to 0. And then here, it's up to you which one you want. You can also choose chars.length if you'd like, since chars and S will have the same length by now. And this will reset it back to 0. And at the very end, we will just print out, not print out, sorry. We'll just return the string that we've built up. Okay, let's try running this code. Make sure everything compiles. Seems like it did. All right. We'll submit and it's accepted. So let's go over the runtime a little bit. So in here, for our runtime, let's have S have a length of n, and our shift will be, I guess, n by 2 matrix. So in here, we read everything in our shift array. So here we're spending O of m time. Now here we do a lot of constant work, just some mathematics. And then here we have another loop. And in this loop, it depends on the length of our string. So the length of our string here is going to be O of n, which is the length of our string. So in total, this algorithm has O of m plus O of n. So you can just call this O of m plus n. So it really depends on which one grows more. Okay, that's the end of day 14, and I'll see you on the next one.